Hello everyone, my name is Rachel, and today we're going to be covering the concepts for the colorful gases activity for the science carnival. So we will go over the concepts behind the emission spectrum and how to explain everything to students at different grade levels. Also covered is the relationship between elements, their wavelength, their energy, and their frequency. I'll also explain how diffraction and interference patterns play a role in this activity. So let's get started. So when explaining this to a group of preschoolers to third grade students, I like to start off by giving them a visual. So different elements stay in different houses, and within each of their homes, they have different set of stairs. Each element goes up a level of stairs, and when they jump down, they release energy, which results in a specific color. The color is based off of the amount of energy the element has. So elements like neon have a short set of stairs to climb up and don't require a lot of energy to jump down. So when they jump down, they give off a fiery red color. Now take an element like helium. It has to climb up a larger set of stairs, so it needs more energy. So when it jumps down, it gives off a purple color. So students within this age range should be familiar with the concept of Roy G. Biv. Within the electromagnetic spectrum, there is a section within the middle of the spectrum referred to as visible light. This is the region where we can see colors that range from red to violet. This is also referred to as Roy G. Biv. The red end of the spectrum has a lower energy, lower frequency, and a longer wavelength. The violet end of the spectrum has a higher frequency, higher energy, and a shorter wavelength. The farther away you stray from the red end of the spectrum, the higher the energy and the frequency increases, and the shorter the wavelength gets. This corresponds with the light emitted from the elements. Elements that exhibit a color within the red family have a lower energy compared to the elements that exhibit a color within the violet family. Students within this age range should be able to connect the relationship between wavelengths and frequency with diffraction and interference. When a wave encounters a slit that is comparable in size to its wavelength, it bends or diffracts around the slit. Interference occurs when two or more waves interact with one another. They either cancel each other out or build each other up. All depends on their interaction. The diffraction of light through the slits combined with the interference results in an interference pattern. The pattern containing white and black areas over space can be seen from some distance. Elements each have a specific emission spectrum, which is a series of bright lights that appear on the spectrum. The emission spectrum consists of bright colored lines at specific wavelengths with a series of black spaces in between, which can be viewed with diffraction goggles or instruments. The energy and color of an element is emitted once an electron makes a transition from one stationary state to another. The color emitted is based on the element's energy and wavelength.